focus is on the genetics of inflammatory bowel disease, and you detected in several GWAS analyses new gene loci for these diseases. So what do you think are the next steps, and firstly, what does it help to have these disease loci detected?
So, I mean, the next steps have already taken place, I would say. So, clearly the new sequencing technology has revolutionized a little bit also our field. So what we are doing is we are systematically resequencing the identified loci in patients and in controls to identify all variants that are there, not only SNP variants, also the structural variants, where about 25% have been missed before in the genome-wide association studies. And this is, I mean, one of many projects. We're also resequencing entire exomes of families where more than one individual is affected with the disease. And I mean, it's obvious if we see a segregation of the phenotype in the family that there might be also, genetic variants segregating with the phenotype.
Okay, thank you. So very often you just find a pure association where you do not know the mechanisms behind that. So we in Munich are working on genetics of intermediary phenotypes, like genetics on transcripts, on metabolites, on proteins. So do you think that could be also interesting for your research?
Definitely. I mean, we're really specialized on, or specializing at the moment in the genomics field, so we're not doing too many or covering too many other topics, but we would certainly be interested in collaborating. And I think it's really smart to generate heterogeneous data sets on the same set of patients or healthy controls, and I mean, and to correlate these heterogeneous sources with one another. You don't learn everything just by looking at the genome. Of course, we need to see, is there a correlation with the transcriptome, the proteome, or the metabolome, for example. But I mean, this would be, for example, a good collaborative project we could do.
Yeah. So we are both on not only working on patient cohorts, but also on population-based cohorts in Munich with the Cora cohort and in Kiel with the PopGen cohort. What do you think are the advantages of these population-based cohorts?
I mean, the advantage is clearly that most of the persons should be actually healthy at the start of the study, and if you're following them up over a large period of time and you're asking after 3, 5, 7, 10 years, for example, again, that you can actually identify persons who got a common disease. It depends obviously also on the number of controls you have, what kind of diseases we find in this subset. And we can more systematically study also environmental factors in these populations, while we are working mostly with retrospective cohorts. The persons are already sick. Thus, we can only speculate what environmental factors caused the disease there. And the genetics sometimes give us an idea what the epigenetic factors or microbial factors could be that caused the disease. So for this, I think it's pretty good, and also to determine more precise measures for the relative risk, which we can only approximate in retrospective cohorts.
Great, thank you very much.